Okay, so I took a look at the first day attendance survey, and some folks indicated that they were a little bit concerned that the class was just going to speed through syntax and you're going to have to do a lot of work on your own to kind of pick up the basics. And that was kind of my original intent a little bit, but then I started feeling really, really bad that people were worried about that. So now what we're going to do is kind of take a step back and do a couple of other programming assignments or programming tasks in Visual Studio with C#, just in case people need a little bit more familiarity with kind of the rudimentary syntax stuff, loops and that kind of thing. If you have already started the programming assignment for week 1, and you are entirely fine, you don't really have any questions about syntax, that's great. You can go ahead and skip this video. Otherwise, I'm gonna try to go through some of these tasks a little bit more slowly and a little bit hopefully less chaotically, and hopefully that helps people who are maybe struggling a little bit. So if you see on my screen, again, I'm going to go to the right-click menu. I'm going to go to Run as Administrator on Visual Studio. The reason is because we're going to be doing things in the class that require elevated permissions, and if you don't have elevated permissions, you get a bunch of weird errors, and I'm not really sure that you want to go through the heartache of trying to figure out what these things mean. Fundamentally, if you have Visual Studio in elevated privilege mode, typically everything is kind of okay. So what we're going to do is create a new project. That project is going to be a C# console app. So if you walked through or attempted to walk through the other video, this should be in your recent templates. And so we can go next. We can call this thing basic syntax walkthrough or something like that. And go ahead and create that. Okay, so we've got our basic syntax walkthrough namespace. This thing maps to the name of our project. And like we said before, everything in C# is object-oriented by nature. So we get this class that is basically just the program that we're trying to write. And inside of that thing, we have a static main method that mirrors exactly what you would get if you created a new Java project inside of Eclipse or something like that. So what I have is a website that has a whole bunch of different kind of programming tasks that is kind of intended for people who have familiarity with programming, but not necessarily programming in a specific language. And so what I'm going to do is I'm going to go through a couple of those tasks really quick, just to kind of make sure that everybody's happy. So the first task is to write a program that asks the user for their name and greets them by that name. So this illustrates, first of all, that you can do comments. Comments work exactly the same way that they work in C or C++. You could also do block comments with the normal sort of block comment syntax. It kind of works the same way. So what we're doing here is we're basically just, again, looking at console reading and writing, so input and output to the console. And so in order to do that, all we need to do is do console.write line and do hello, what is your name? So then what we need to do is we need to store the value of that person's name in some sort of variable. So here what we're doing is we're setting up a new variable called name, and we are setting that thing by default to an empty string. So this illustrates a couple different things. So first, this var keyword, again, just allows the type of this variable to be inferred from the right-hand side. So this thing is a string, so this thing is going to be a string, and we didn't necessarily have to explicitly declare it as a string. We could, if we wanted to. It's going to do exactly the same thing. What I typically do is use var whenever I can. It kind of makes things easier to read, in my opinion. It's kind of a personal preference. So the second thing that we haven't necessarily gone through is what string.empty means versus this. So string.empty is a string literal that gets carted around everywhere, and it has one sort of address that it can always be accessed by. It's a best practice to use string.empty instead of just an empty string, and the reason is that every time you create a new variable and you set it to a different empty string, you're technically using some space that you otherwise don't necessarily have to use. Strings are immutable, so if you do string.empty, technically anytime that you reference string.empty to initialize any string, you're making use of that same space, that same allocated space, so you're being less wasteful. For the purposes of this sort of a whole course, it's not going to be a huge deal if you use either or. I'm basically just showing you all the different ways that you can do stuff. So this gives us somewhere to store the person's name. So the next thing we need to do is actually read in that person's name. And so we can do that by saying name equals console.readLine. That will actually set the name, and then we can do console.writeLine. Hello. Name. Okay. So this is the sort of standard kind of naive way of doing things. We're using string concatenation, as you probably have seen it many times before. And if we run this thing up, you're gonna get some weirdness because I forgot something. That's okay. I can say my name is Chris, and oh my gosh, it went away. And the reason is because I didn't do that. So now if I run this again, and so now, because I've added this extra read line, it's now waiting for user input before it closes the terminal window. So this is an option somewhere where you can make Visual Studio not close the window, sort of like the experience on Mac, but I've never cared enough to sort of go looking for it. So I usually use this approach to just read an extra line at the end of the sort of main method. So if you're working on your programming assignment 1 and the screen or the terminal window keeps closing when you don't want it to close, this is probably what you're missing right here. Okay, so that's the first task. That's sort of happy. Hopefully it kind of makes sense. Cool. Oh, well, the next task is to improve this thing. So the next task is to ensure that it doesn't matter if the name has a lowercase character to begin it. We want to make sure that the top or the first character of the name when we write it back is capitalized. So what we can do here is we can do name equals name dot, or name at 0, car.toUpper on this thing. Yep. And then we're going to do one. So now, if we run this, Now, it doesn't matter that I gave it a lowercase c. It's always going to greet me with a capital C for my name. So we can walk through this really quickly. Exactly like strings or C strings in C++, you can index a string to get the characters out of the string, and that's what I've done here. The first index is just the first character in the string. I've used toUpper from the character class, so this is actually the primitive type car, and I've used the toUpper to cast this thing to upper. There's also, like we were talking about last time, some culture information that you can use. Typically when you're doing this kind of stuff, the standard culture is okay. If you're doing something on strings that have sort of standard Roman characters, you would want to use the appropriate culture to get the correct uppercase symbol. But here, that's kind of okay. Here, what we're doing is we're using the substring method on the string class. So this is saying I can give it one parameter. This is starting at the first index in the string. It's going to go all the way to the end. I could also pass it the length that I want to go. So if I only wanted 3 characters afterward, I could put a 3 here instead of leaving it blank. So this goes from the start index to the end of the string. Note that I'm also, again, kind of using this weird, not weird, it's the least weird string concatenation. Instead of doing that, what I could do is use string interpolation, which is another thing that we talked about in the other code along video. So in order to do that, all I would need to do is this. So here, what is happening is I've used this $sign. The $sign is telling the compiler and the interpreter and the linker and all of that this string is going to be comprised of actual code that's going to run. So what's going to happen is it's going to go to each of these curly braces. It's going to run the code inside of the curly brace and then replace this whole bracketed component with whatever this evaluates to. So in this case, this part is going to evaluate to the capital first character, and this part is going to end up being the end of the person's name. So here we could do exactly the same thing. So I can change this to a $sign and put the name in here. And then run that. And it's the exact same thing. There's not really a best practice associated with this. I just think that this thing is kind of cool. I think it was added in .NET 4.6.1. It was quite a bit ago. I think it was right before the fall 2019. So this, to me, it just makes it a little bit easier to make sure that you're actually putting your strings together correctly. One thing that happens a lot is you'll miss things like this blank space here if you're not careful, if you're trying to concatenate with plus. So it just kind of makes it nicer. So that is that one. Cool. So the next task is to ask a user for a number and then print the sum and in product of all numbers from 1 to that number. Okay. So again, we're going to start with a console.write line. Hello, give me a number. Then we're going to have a var number, and we can set that thing equal to 1 or to 0. So one thing to note is that as long as you're using var, you have to initialize the variable. So if I try to do something like that, it's not going to know what the heck the number is going to be in terms of type because I haven't given it a right-hand side. So if you did not want to do that, you could always just make it an int, and then do number equals console dot write or read line. And so this goes back to the parsing discussion that we had in the other code along. So we're going to do this one a little bit slower and less chaotically to make sure that everybody kind of follows along. So what we could do is int dot parse. And for right now, we're just going to do console dot write line and parrot back the number. So console dot read line. So if I run this, it lets me give a number, and if I do 10, it's 10, everything's cool. But if I do pigeon, I get a crash, everybody's sad. So you don't necessarily want crashes. So I can get around this by doing something like if int.tryParse console.read line out number parrot back. And then else. So this should fix our issue. So if I give it something like dog, it tells me, hey, that's not a number, stop being a lame user. And it is much less abrupt than throwing an exception, which is kind of jarring. So this is something that we did a couple different times in the other video. We were trying to do a whole bunch of stuff at the same time. But the long and short of it is you can blindly parse the string into an integer, or you can kind of safely do it. This is a way of safely doing it. If tryParse is successful, the whole method returns true, which will drop you into the if statement. And it will also return the value, the int value of the string in the number, so we can easily parrot it out. Okay. So now, instead of parroting, what we want to do is we want to have two different values. So you want to have the sum aggregator, and we want to have the product aggregator. And they can both be ints because we're accepting just a whole number. And instead of parroting back the number, what we want is we want to use a loop that will go through all of the values from 1 up to that number and store the sum and the product in these respective variables. So the most appropriate loop for that task is probably a for loop. So we're going to do for int I equals 1. We're going to do I is less than or equal to number. And we're going to do I plus plus. So like we were saying last time, for loop, exactly the same as C or C++. You have the initialization, you have the condition, and then you have the update. And so inside of this, I can say the sum aggregator is going to be plus equals I, and the prod aggregator is going to be multiplies equals I. And then we're going to be able to console.write line. We can do string interpolation, to say the sum is going to be the sum aggregator and a new line, and the product is going to be the product aggregator. I may have missed something. We're just going to go with it. Okay, so if I give it 3, the sum is 6, the product is 6, so the product would be 1 times 2 times 3, which is 6. The sum would be 1 plus 2 is 3, plus 3 is 6, so that seems kind of nice. Everything's happy. If I use a test case that is not quite as easy, and I give you 4, I get the sum is 10, and so that is 4 plus 3 is 7, plus 2 plus 1 is 3, plus 7 is 10, and so then the product is 2 times 3, which is 6, times 4, which is 24. So that kind of makes sense, and everything works out. Cool. That is the second one. So the last task that I want to do in this video is to take a list and do some various stuff with the list using some methods. So to kind of illustrate the encapsulation stuff that we're trying to work on before we get into object orientation proper next week. So I'm going to do this one a little bit seat of my pants. It's not on this in its current form. I haven't read through this whole list. It's not in the list of exercises on this site. And I'm actually going to put this site up as a resource in this particular video's page on Canvas. Because if you want additional practice, this looks like a really great resource to me, especially if you have some experience coding already, and really it's just the language features and syntax you're kind of worried about. So what we're going to do is we want to have a list of numbers, and so we could have a list of int and call it my nums. And that's going to be a new list. And we're just going to give it 1, 2, 3, 4, 5. And so what we've done is we've initialized to a list of integers 1 to 5. It works largely the same as you would expect from any other language. We could also have, we'll actually call this my nums list. We could also have an int array. And it also works exactly the same. The syntax is identical to Java or C or C++. And really the difference between these two things is that this guy has all of the same sort of limitations that you would expect an array to have. There are library methods off of the array class that allow you to do things that you wouldn't otherwise be able to do in a language like C very easily. But even with those library functions, lists are way easier to deal with from a data access perspective. So most of the time when you're coding in C#, most of the code that I have seen has used some variant of list. And a lot of that is around the fact that we are using not necessarily the most bare bones language, and we're not necessarily using the smallest framework ever. So there's some performance impact that you expect from using .NET to begin with. And so, like I said a couple of times in the last video, if you're trying to write the world's fastest piece of software, C# is not the thing that you're trying to write in usually. C# is very, very, very good at really rapid development. It's really, really good at server-side sort of web service development, which is a thing that we're going to spend quite a bit of time on in the class. And so trying to kind of micro-optimize every flop out of your code is not necessarily a thing that it's going to get you very far in this particular aspect of the coding world. So this is how an array would work. It's basically everything that you've learned about arrays applies here. You can use whatever algorithms you want to do whatever you want. But what I want to show here is that we can do things on a list with methods that are maybe kind of interesting. So what we can do is say we have a new list or a new method. So we want a public static sum method. And what that method is going to take is a list of ints called numbers. And what it'll do for right now is just return the sum. And so console.write line, and we're going to call sum of my nums list, and run it. And so here we get 15, and so that would be 5 plus 5 plus 5. So that's all good. We get what we expect. This illustrates kind of very rudimentary. This is what a method signature looks like. This is what a call to a method looks like. None of that should be super shocking. And we also have these kind of nice helper library methods that hang off of these objects. So but by virtue of my nums list being a list, you get a sum for free. We could just as easily have done something like int var aggregator is 0, and then for each maybe var num and numbers. I'm going to do ag plus equals num, and I want to return ag. So this is an equivalent way of doing exactly the same thing. We get 15, everybody's happy. But here what we've done is we've used this kind of implicit enumerated for each loop instead of a for loop like we did up here. Syntax is identical to the Java. I believe that it is for object or type variable name in some my list, something like that. So in this case, it would be for int num in numbers. If you're familiar, I think that was added in Java 8. I could be wrong, but it's equivalent to that syntax. We were talking in the lecture about how for each has some bad properties if you're trying to change the elements of numbers, the numbers list inside of this, but here we're not. All we're doing is we're adding to the aggregator, so this is entirely fine. This just shows you an alternative syntax for a loop. It's equivalent to using a while loop or a do while loop or whatever. It gets the job done, and a lot of it's personal preference. It's 6 of one, half a dozen of the other. So this is a pretty simple method, but we could also do something like public static int min list int numbers, And so here, what we want to do is we want to return the minimum. So we can again start with return numbers.min and console.write min of my nums list. And you would obviously expect to get 1. And so here we do, in fact, get 1. But if we wanted to be a little bit self-harmful and do var min is some hilariously large number, like in max value, for example. And then for each var num in numbers, we do an if statement. So if num is less than min, min equals num, and then we could return min. So this would be an alternative implementation, gives me the same result. I've just typed more. So this gives you an example of what a conditional looks like, again, using logical expressions, evaluate to a Boolean exactly like you would expect. Gives you some exposure to things like in.max value. What you'll find is that the library methods and all of the framework around C# and basically all of the CLI languages is such that if you're trying to do something and you feel like it has been done before, you should be able to type something like a primitive type name and hit dot. And then IntelliSense in Visual Studio will tell you a lot of the available kind of methods or properties, max value, min value, whatever. You can do exactly the same thing for something like numbers, the list. So we can do numbers dot. And here you see I have a crazy number of things. And so we have stuff that's like you would otherwise have to implement yourself, like a binary search, for example. So binary search, and then it actually tells you all of the overrides and the hover over. So there is a little bit of kind of Wild West exploration to the language, and if we try to go through all of the libraries and all of the methods in each of those libraries, we could easily fill the semester doing that. I just kind of think that everybody would be happier and they'd get more out of the class if we kind of moved on. So if you have trouble doing the programming assignment, please let me know. I'm happy to answer specific questions. I'm happy to have one-off office hours and kind of code through it with you if that's a thing that needs to happen. Come to office hours. I'm happy to screen share whatever we need to do to make sure that everybody's kind of comfortable and happy with the language. So that's really all I had planned for this. Please let me know if you have questions, comments, concerns, or anything like that. Let me know if it's helpful, and I hope that I will see you all soon. Thanks very much.